All right. It's great to see you all here. Thank you very much for coming to this. For those who've come from near and those who've come from far, right? There's people coming from all over the place for this one, so it's really good. Thank you very much. Good to see you all. I just wanted to say welcome and welcome to Microsoft Research. I don't know how many of you have been here before, but there's people who used to work here and people who have been here before on internships and things like that. But it's certainly good to have you all here. So we're here for this workshop on tasks, generative AI, obviously two very hot topics right now. The event's going to last about a day and a half, right? So we'll have a mixture of different things. We'll have talks, we'll have panels, we'll have breakouts, a lot of different things. We'll have posters in the afternoon. People will have an opportunity to speak about those and hang them around the room and stuff. And I really think the main aim of this, though, is really to bring us all together. We're all kind of interested in this broad space, create an opportunity for us all to speak to each other, engage, learn, connect. So that's the main aim. I want to thank a few supporters of the event, NSF, SIG-IR, the Information School, University of Washington, Microsoft too. They all played an instrumental role in making this event happen. An important thing, as I look at you all, dive for your laptops, and if you want to be able to access Wi-Fi when you're here, this is the information. So the SSID is Microsoft Guest. You just open any website, and then you click on enter event attendee code, and then enter co-pilots. Right, so that's these days, Microsoft's talking a lot about co-pilots in the AI space. So we thought that would be an appropriate password for the access. I'll also put that up here as well. You don't have to pay that much attention to this. I just wanted to start by just providing a little bit of background on MSR as well. I don't know how many of you know about Microsoft Research. So the organization was established in 1991. We have 10 labs all over the world, 8 different locations, about 1,000 employees in MSR. So we have, we are obviously in Redmond, but we have labs on, the East Coast in the UK and India and China too. So really all over the place, which is great. I mean, it basically means we can establish labs where there's expertise. We can take advantage of that. A little bit about what we do. We really do 3 main types of things: product-aligned research, disruptive research, and exploratory research. And we care a lot about impact. So we're going to tag team this intro. I want to hand over to my co-chair, Chirag, who's going to speak a bit about the event, how the event came to be, and provide a little more information about the plans for the next couple of days. So thanks.
Thank you, Ryan, and welcome again, everyone. I'm Chirag Shah. This workshop we planned 3 years ago, but something happened in early 2020 that made it not so possible to bring this many people together in space. And I remember Ryan said, well, maybe let's wait for the fall. And we can't do that in summer. Okay. We waited till fall. I was like, one more month, if you remember, Ryan. So we thought it's just like, okay, well, we couldn't do that in that summer that we hope, but we continued postponing it. And every summer since then, we're like, yeah, it's going to be this summer. We could have technically done it last summer, but again, there was a little bit too chaos going on. And so the project, this workshop was primarily funded by National Science Foundation in the US. And NSF has been kind enough to keep giving us extension, except that now this time it's like, well, third time is the charm. Either you do it or just forget about it, because if we can't do it now, I mean, I don't know what better circumstances we're expecting. We are in this situation where we're going to have to just learn to live with this virus and the situation we have. So we finally decided, okay, well, this is not only just we have to do this now, but it's also a better time. It's also the right time when the focus on some of this information retrieval problems, especially things related to tasks, is just taking a new light in the context of generative AI, right? And so some of us have been working in this space now over the last year or so, and been really excited about the new possibilities. So then this became not just yet another workshop where we just get together and do something that, it's still productive, but it became this like new exciting opportunity. And so we finally grabbed onto that and made it happen. I know you probably learned about this workshop not too long ago, but it wasn't like we were hiding it, but that's how we organized it. So everything was really moving fast, but we're really happy that you made it here. You can see our workshop topics. You don't have to read it. It's also on our website. But we tried to be as inclusive as possible in terms of the IR side and the AI side. And here, people have come together from kind of both ends of the spectrums and everything in between. So we were really happy about that. We have people coming from all over the country and even outside of the US. I'm particularly excited about all the students we have. So can you raise your hand if you're a student? And others can look around to see. This is great, awesome, fantastic, welcome. So we are really looking to you guys to help us figure out some of the tough questions. And as we get into the breakout sessions, hopefully, at least I encourage all of you to speak up, but we definitely want to hear from you, because some of the old timers have some, stagnant ideas, and you have to come and jolt us. So I'm glad you're here. It is a workshop. This is not a seminar. This is not a tutorial. This is not just some conference you go and sit in the back and just listen to some things to learn. You can still learn. We are all learning, but please participate. So this is the key. So we're going to hear from some people this morning, this afternoon, but most of what we are going to do is really participation. So here's our agenda. Again, it's available on the website too. We might have a little bit of like improvisation and changes if we feel like, but we're going to start this morning with a keynote. We'll have 3 invited talks, the short talks. So this is a way to just get us started in like get us rooted in this space and start learning about what people are interested in. The lunch is right here. It'll be, again, food will be set up outside. The drinks will be inside. You can move around this space. We are in this Microsoft Research Building, or Building 99, but we don't have access to the rest of the building. But the bathrooms are right in the lobby here, and we have this whole space that we can use. So feel free to move around. You can, of course, go out. Not a great day to be out, but tomorrow is supposed to be better. Afternoon, we have the breakout session. The first breakout session, we'll break into 4 groups. We have table captains for them, and they will kind of coordinate their groups. We'll give you a little bit more instructions when we get to that. Coffee break, we have a panel. So we'll set it up here. And then we have poster presentations. And we'll start by and this is mostly targeted student, but don't be offended if you're a non-student and presenting poster. We love to hear from you. This is just a way to have more voices heard. And it gives us a chance to kind of move around and freely talk to one another. And that's where we're going to end today. So we'll hopefully end before 6 o'clock. Again, it's kind of rough estimate. At that time, we'll see. Dinner is on your own. And that also allows you to just kind of figure out your own agenda and have some freedom, flexibility. So we hope you take advantage of being here for that. Tomorrow we have half day. We'll start with breakfast. Once again, the food will be set up outside, drinks will be inside. If you come here before 8 o'clock, you may not be able to enter, as some of you discovered today. I think we emailed this yesterday, but it's possible some were in transit and missed that. We also have Slack channels. So if if you're not on Slack, please see if you can, because we can exchange a lot of these kind of like minute instructions, details there, instead of finding emails and doing that. Plus, on Slack, we can also organize some groups, like for students, for breakout groups, for anything else that happens, because we're hoping that we can continue some of these conversations beyond this workshop time. Right, so that would be a good way to stay connected, network, and make some possible collaborations from there. The last session we have tomorrow, so we have another breakout session in the morning, but the last session we have is intentionally kept as like a wild card session at this point. It's just put it like we're going to bring the full group together and have discussion. But honestly, Ryen and I will be talking tonight. It's like, what are we going to do tomorrow? So if you have any ideas in the meantime, certainly reach out to us. But we just wanted to see how today goes, right? And then see how we can leverage that time together before we leave to make the most out of it. My personal view is we should be using that time in some way to set up the agenda going forward. Like what comes next? What's next now? Are there some ideas that maybe some of us want to pursue together? Is it something that we want to disseminate to the community, in terms of some report? I mean, I think we should definitely do a report of some sort. We have thought about doing a report in Cigar Forum, but there may be other avenues. So we'd like to hear from you, and again, we'll engage in some discussion there. But that's not it. We're actually going to have lunch here. So we'll feed you before we say goodbye. And that would be it. One of the reasons we organize this way, Thursday, Friday, is to also allow people to just hang around. Seattle is a beautiful area. I mean, at least those of us who live here, we certainly love it, enjoy it. The weather today doesn't, vouch for that, but rainy season is coming. And actually, honestly, we do need rain. We've had pretty dry summer. So this is actually quite welcome. But the weekend seems really nice. So if you could, I would encourage, staying around in this area, checking out. Okay, so Ryen, remind me if they have to do the badge collection tomorrow as well?
Yes, they do. So you've got to go to the front desk tomorrow and get your badge as well. Microsoft will only give out a badge for 1 day at a time, so you have to do it twice. Sorry.
So if you got 2 different emails from Microsoft, that's okay, because it's like one for today and one for tomorrow. They don't recognize that there is just the one event, so you're visiting 2 different days, and that's what it is. Those who brought posters, we can you can start hanging them from, say, lunchtime. Bathrooms, I already said. We're going to record some of the sessions. So the keynote, the invited talks, and the panel, those will be recorded. We're not live streaming this. This is not a hybrid event, so we don't have any online participation. And that was intentional. I know that seems like not so very inclusive, but just the nature of it, it's just too much logistically to have online people participate really actively in breakout sessions and stuff. But instead we decided we'll record some of these things and make it available mostly through Cigar channels. So it would only be the speakers, those who are here, they will be recorded, not the audience. We did ask for consent, because we'll be taking some pictures, and I hope that everybody's okay. Like, we're not going to sell this, or I don't know what we're not going to do anything. We're not going to feed it to some generative model to train on. At least I can't guarantee what would happen, but the idea was we'll just put it up on some shared Google folder and share it with everybody. So whatever you want to do with it, that's fine. But that's our kind of plan. Okay. So finally, I want to thank our couple of people. So Mariam, who's a UW student, one of my students, thank you so much for all the work that she has put in. You probably heard from her. And Sarah Clark, who's from the Microsoft side, helping us or coordinate this. So thank you, Sarah. There she is. Okay, so with that, we can start with our agenda, and I'm going to invite our keynote speaker. So we're lucky to have Nick Craswell as our keynote speaker here. Nick is a principal applied scientist at Microsoft. Over many years, Nick and I have had our paths cross in all kinds of interesting ways that some of that Nick doesn't even remember. You remember me meeting at MSR Cambridge?
Oh, wow.
Long time ago. When Steve Robertson was still there. You see? Most recently, we met in Melbourne. And so Nick has been all around the place, but one of the things that is really exciting for me and for Ryen also is Nick has been actively working in this space of generative AI, and he's got some brilliant and wild idea what he calls speculative, which I hope he gets to present some of those things. But some of the things that he's been working is very, very relevant to all of us here. He's been focusing specifically on evaluation, specifically in M365, which is the suite of products at Microsoft, and he hasn't published on some of those things because some of that is confidential, but he has done a lot of other publications. You may know MS Marco. So you have Nick to thank for that evaluation, that data set. Nick is a member of the Cigar Academy. So that's a big, distinguished kind of recognition. And he's just done tremendous amount of service to the community and scholarship. He has published hundreds of papers and 3 books on information retrieval and access. So thank you, Nick, for joining us, and look forward to hearing from you. Welcome, Nick.
All right, thanks. So this is a talk that I gave it was a workshop keynote at the web conference in Austin in May. And I had this issue that I wanted to talk about some of the GPT-4 kind of stuff, but I didn't actually, 1, really understand it, or 2, have a good way of talking about it, because a bunch of stuff that's going on is internal work. And I was even still learning about the internal work, much less knowing what I could say publicly. So what I've decided to do with this talk is basically not talk about, obviously, the product, because I now know a lot more about how the product works, actually, like Bing Chat and Biz Chat or M365 Chat are these products that are using GPT-4 kind of things. So I'm not going to talk about those details. And in fact, the examples here are almost a bit off, because they're really just my toy examples in response to my published research. But I still think it's relevant because we face some similar issues. And in fact, last week we published a preprint where we actually did talk about some of the stuff that was done in Bing. And so what I've done is I've actually dropped in slides since the Melbourne version of this talk. And so we'll have to see how we go with the timing of this talk, because I've now dropped in a bunch of new slides. And so just warn me and stop me at when I run out of time. But I thought it's fun to put in the actual thing we published preprint last week. So 3 areas. One is just fundamentals, like MS Marco had an impact, but do we need another one is an interesting question now that we've got these models and we can generate synthetic data. Another one is, can you do similar things with synthetic data and other things with personalized search? So I just had some explorations and toy examples there. And then conversation, I had some toy examples too. Just like coming into, we had this theoretical framework for conversational search. Like, let's think of some of the ideas in that and see if GPT-4 can do such things or something like that. So that's the outline. And then I dropped in the stuff about synthetic data at Bing kind of here. So we'll see how we go with that. Okay, so I'm just going to describe what is MS Marco, why we think it helped, but then question, do we need another one? Do we need another data set like MS Marco? So the outline or the timeline is that like in the 90s, you had things like BM25 as a ranking feature. In the 2000s, we learned how to take such features and do learning to rank better. The field made a lot of progress. But we reached this point where there was work on deep learning in other fields, but we're working with data sets that have 100 queries, and it's hard. You don't have training data, basically. So there was this phase, like before we had a lot of training data, people were using even synthetic data or generated or kind of like rule-based data even then. But there was this phase where we wrote this FNTIR preprint FNTIR article, An Introduction to Neural Information Retrieval. And it was basically saying, on proprietary data, we can do much better than before, but on public data, we can't, and here's what word2vec looks like, and things like that. Then there was this inflection point in late 2018, but it kind of happened in 2019, where we said, oh, here's a lot of training data, that was MS Marco, and also we had BERT as well. So suddenly a lot of stuff happened very quickly. And now we've had another interesting inflection point that I'll talk about. And each one I've shown a book that people wrote. So, the FNTIR summary of this phase. And then this is Jimmy Lin and co writing about the BERT and T5 kind of phase. And then there's like, what's the book going to be? Yeah.
Are you going to be sharing these slides?
I haven't shared the slides before, but now that it's being recorded, I guess maybe, I think maybe what seemed like I shouldn't share the slides in April, now it's so much later than April. So, in deep learning terms,
My level of note taking. Okay.
No, I mean, I think I could share some version of these, I guess, if it's being recorded, right? Yeah. Okay. So this turning point went from having no training queries to having hundreds of thousands of training queries. And beforehand, there were things like these papers on the left are saying, well, the improvements aren't adding up, and it's neural hype and weak baselines, and nothing's really working. Although we did have our thing saying on proprietary data it works, because we have 100,000 training queries in Microsoft. But that was like this phase. And then later there were these papers where we said, okay, actually here's a data set with training data, here's how you rank with BERT, here's Jimmy's book, and here's at the bottom it's the neural hype justified a recantation, so like everything turned around. For this talk in May, sorry, I should say May. I wrote the talk in April, but for this talk in May, I actually looked up the date at which these things were released. And actually BERT and the MS Marco ranking leaderboard were released on pretty much, the 25th and the 26th of October 2018. So like very, very close. And then it was in January that then BERT was at the top of that leaderboard. So it all happened very quickly and simultaneously. I just wanted to clarify one thing, because the MS Marco dataset gets cited as a 2016 paper. And the reason is that it was an NLG dataset with 100,000 queries and then it got expanded to 1 million queries, and we added the ranking task. And the authors of the original one said, well, okay, we need to add more authors to this paper. That was their solution to updating the data set. So there's a weird thing on arXiv where there's 2 versions of the paper and they get cited separately, and they were submitted at different times and things like that. So I say it's 2018 because it was the 2018 version that had 1 million queries and had ranking in it. But a lot of people talk about ranking and they cite the 2016 version, which is kind of not the intention of, I guess, the publication that people would do that. All right, so I've left out a slide that says, hey, we did much better than the old models using BERT and things like that. And actually, maybe that's the green. So ignore the red in this table at first. So what the green column means, maybe I'd rather point using this kind of pointer. So there's a green column here. And what it means is here's a whole lot of ranking approaches that do better than BM25, because I've made BM25 0, or one version of the kind of 1990s ranking technology 0. And then here are all the other things that beat BM25. If you train on these hundreds of thousands of queries, you can do much better search. That's what this green means. But what people observed is, well, fine, if you've got I don't know how much MS Marco costs, but if you've got $1 million to spend on labeling, you can, do much better. And it's maybe that's impressive, maybe that's not, because it's how often are you going to do that? So the question is, would it work on some other data set? If I took the training data on MS Marco, which is Bing queries that are answerable by short passages of text, and then a corpus of text passages, and you're trying to search those, would that help you search newswire data or health-related data or things like that? And that's what all the red means. So if you take all of these things these same rankers that look great on the test set, in domain, and you try them on some other domain, you get all of this bad stuff. So, one of the columns here is a data set called Robust04, which is a very well-known kind of newswire data set. And you can't, we thought we were doing better than BM25, but we're actually doing worse on all these different data sets. And on average, it's looking terrible. So it's we thought we got a big win from training on the MS Marco data and testing on the MS Marco data. But if you try and apply it anywhere else, you actually don't do well. Yeah.
So there's that one little green column. What are the characteristics of that data that make it similar to it?
I think it says NQ.
Natural question.
So that's, it's probably the most similar data set among them, I would say, to MS Marco. Yeah, I think that's ooh. So there's another version of the leaderboard that doesn't show all the negative results, but shows that we made progress. So because there's two versions of the leaderboard, I've got a different slide for it. So people have made progress on this problem and got more green on all these different data sets. And the way they've done it is usually by processing the corpus. So if you get a bunch of health data, you need to process the health data in order to learn to rank on the health data. And one of the things people do is they do synthetic data on the health data. So they might use a T5 model or even a GPT model to generate, given a health document, let's say, let's generate what's a good query for this, and then tune your retrieval system to, towards that data, basically. So it's kind of we'll talk about this, but it's kind of like distillation. You're saying I'm going to grab some data, that's generated by some more expensive model, and then I'm going to train a retriever that can operate over millions of documents and efficiently. That's like the student. I'll keep going. People did start using, this is from almost a year ago, this Stanford benchmarking. People, and they did include two versions of the MS Marco data, which is in the top right there, but they benchmarked a whole lot of language models with a whole lot of tasks and a whole lot of dimensions of analysis. And they did start doing ranking using these LLMs. They also started doing labeling using these LLMs. In fact, their approach was kind of both at once. and they tracked how things improved. And so we did see over time that two of those lines are MS Marco, and they when a few of them jump near the right, up in quality, that was this is showing the best performance over time on each benchmark. And there's a couple of MS Marco lines that did improve as the LLMs got bigger. So they're doing that kind of thing. Let me come back to it. I'm going to talk about it in these inserted slides. So yeah.
Can I ask a question? So you're showing all these lines, and what are the metrics here?
Yeah, so these are many benchmarks. So basically, Helm is basically just doing let's take every up to search data sets, but also many different NLP tasks and many kind of things, and just benchmark everything, every LLM for every task.
I guess I just meant with the IR tasks specifically.
Oh yeah.
Are there any metrics where it actually goes in the opposite direction, where you get more red?
I didn't see that here, although this is the best possible performance. So I guess it's hiding a lot of regressions that happened when new models were shipped as well. The only certain one of these models helped with their prompt, I guess, for MS Marco on NDCG or whatever. Yeah. All right. I will keep going to get to the inserted slides. So in this version of the talk, I was also just saying, hey, I just edited this slide and typed 3 at the top just before I came in here today. So this is actually GPT-4, the DV3 model. All of the examples I have, the toy examples I have in this talk, are things where I didn't iterate that much. I just wanted to show what it would do if I did some toy examples. So let me just show you what I did here. I took the workshop web page, and I made a prompt where I just said web page content, and then just copy pasted the content into here, and then said queries. If someone was searching for this page, please list 10 different queries they might type. And then you get a bunch of queries. And one thing I did was I looked at how often each of these queries occurs in the text that was given. And the answer is how and submit didn't occur in here, but everything else did occur in the page that was given. So it's kind of just generating these very verbose queries that are, not really exactly like what real user queries look like in many cases, but they're kind of reasonable queries. And why would you do this? Because the MS Marco data set is query document pairs. So I've just generated 10 query document pairs here that could be used as training data or test data or something like that. And then because they're so long, I just added a thing and said, hey, actually, no, not even because they're long. I tried to actually fix the vocab overlap problem in this case. So I said, it's okay, they're still long, but at least use some vocab that's different. I said, try and use words that aren't already in the page. And it kind of followed the instructions. So maybe through prompt stuff or something, instructions, few shot examples, you can get it to work better. And this is what one of the approaches here, in parse, is doing this. That kind of approach is that you just generate queries for the given content, and that becomes your new MS Marco style data set. I had this point that's a bit of an awkward slide, but I'll mention it. So if for some reason you wanted to predict the decisions of a judiciary in some fictional country, and if that country has some corruption, and if you wanted this is all a bad idea. That's why it's called irresponsible AI. and if you wanted to then come up with a prompt that helps you predict the judge's decision, and you're doing prompt engineering, then you could say, okay, well, I need to know, has the judge been bribed or not, so I can better predict whether this judge will, what will the outcome be, or how have they been bribed. So that was all a terrible idea, but you could do prompt engineering to better match a real-world data set, and that's kind of like how supervised learning works, right? Or if you're in Facebook and you want to know if things will be good things to show, then you could say, well, let's just look at what people click. And then you find out that, people click or engage on things that have enraging content. And enragement equals engagement. So if you want to optimize for engagement, you need to come up with a prompt that can figure out what's going to make people really angry. And again, you're matching some real-world data set, but actually it might have long-term effects on your whole brand. Actually, it's actually very difficult. You shouldn't be doing this. So there's this kind of thing that I wanted to just call out is that that somebody might say, well, synthetic data is good if it matches some real-world data set. And I think we're in a weird case here where people are generating synthetic data that isn't strongly supervised by a real-world data set. And so what biases does the synthetic data have? I don't know, but also should it learn whatever biases are in the real world? I think not, actually. So, okay, so let me get on to the inserted slides from our preprint last week. So there's a thing, lots of people are publishing papers in NLP and many areas saying, you can replace crowd workers with large language models. Actually, if you try and call a crowd provider, behind the scenes, the crowd might be cheating and calling GPT on you and feeding you the results as well. But there's this thing, I think there was a paper published that said it costs 20 times less. And it's easy to work with. In my case, because I work in Microsoft Office, it's kind of interesting that an LLM can look at data that I'm not allowed to look at with my human eyes. But also, is this a good idea? Does it make sense to have the metric and the system be machine learned? And I would say kind of if it's like distillation. But how does this? How do you verify that this works? And there was a paper that won the best paper award at ICTIR recently, sorry that the title is so small, but it's Perspectives on Large Language Models for Relevance Judgment. I should have listed the title more clearly, but there's a whole the spectrum from purely human judgment to fully automated judging, and probably we want some human checking and auditing of this stuff. So going back to a year ago, I mentioned that this Stanford benchmark had a prompt for MS Marco, and the prompt was passage, here's the passage, query, here's the query, does the passage answer the query, answer, and then they can get a yes, no, and they can also, if they want to rank, they could look at the probability of generating tokens, yes and no, and get a score. And so they were doing this stuff, publishing this stuff last November. This paper, that I just mentioned. You can see the title a bit more clearly, but still pretty small. They had a couple of prompts that they used, and one of them for MS Marco is very similar. So what we did in our paper related to this is as follows. So the traditional, so this was the preprint. Large language models can accurately predict searcher preferences, and this is work done internally at Bing that they decided to publish. And they decided to publish it by revealing some relative numbers around how this worked in Bing, but also replicating it on this Robusto4 data set, which is a public data set. But traditionally, if people have worked on crowdsourcing, traditionally how you improve label quality is you have these two dimensions here. One is the cost of getting the labels, like how easy can I get these at scale or not. And so over to the right means that it's hard to get a lot of labels, and on the left it's easy to get a lot of labels. We'll also show throughput and other things in the next slide, but then there's also accuracy. There's an interesting question of how you measure the quality of the labels you're getting. How I've always thought about it for years is that there's a real user. There's also kind of the product point of view. Sometimes you want to protect the user from some bad content, and so you kind of overrule them sometimes. But let's ignore that and just say the real user is the one who knows what they're searching for. And if the crowd worker says, no, you're searching for something else, then the crowd is wrong, because actually the person is doing a search. And this is the case where we've gotten careful feedback from the user. This is exactly what I wanted for this query. And so that's the kind of highest cost, but highest accuracy, which is why there's this arrow in the top right. Like there's a great source of knowing what people want, which is to ask them and get their careful feedback. Then typically the process has been pre-LLMs is to say, okay, we're going to study these users. We're going to talk to them. We're going to get their feedback and their complaints. We're going to run user studies. We're going to run surveys. We're going to find out what they want. We're going to see where things go wrong. We're going to look at maybe do data mining on all their behavior. And we're going to understand everything we can understand about what users want. And so, for example, Google write 170 pages of guidelines about what they learned about users, right? This is what we think is important for users to get a good Google result. So there's this process where the employee working with some like auditors, I guess, or some additional people, will say, here's the definition of what's good, and then they teach the crowd workers, these guidelines. And I guess if it's very low-cost crowd, you can probably only have very short guidelines, and they may not read them. But if you have, I'm kind of saying crowd here also as maybe sometimes there's people who you can afford to teach these long guidelines, but you can also just monitor them. So you can say, I have a very small amount of real opinions from users. I have some very careful people who looked at real users and also generated labels. So I call the top right is gold labels, next is silver labels. And then you can monitor these workers according to the silver and gold labels. And so the y-axis here is how much do you agree with the gold labels? And the gold labels being the real searcher. And so the employees at Microsoft were a bit better than the auditors at this. And the auditors were a bit better than were that much better than the crowd. So that's the game you're playing.
Sorry, a question about the employees. Were those like science employees or research or developer employees, or were those?
These are the people who are working on the guidelines and being like super careful. Yeah.
They would be extremely skewed. Right?
Yeah. Well, no, yeah. But if you have the real user opinions, then you can say, yeah, look at them not matching up to the real users, right? They're not quite, reading people's mind. Because really what you want in this is to read the mind of the user and predict the opinion where they didn't even type a proper query. And they still will tell you, no, you're wrong, I wanted this. That's the kind of thing you're trying to predict. Yeah.
The scale on these things, so is it relative? It's not relative to the real user, like.
No, it's relative to the crowd. So we had to pick a relative point. So yeah, and this is annoying because we just didn't want to just publish the numbers from Bing, but we wanted to give this notion. And also, I should say that everything here was good enough to use. So it wasn't like relative to crowd who are unusable. So like everything was kind of okay. So here's the headline result. Which is the tricky thing that was done is to say, let's take a small amount of gold labels from the real searchers and use that to engineer a good prompt. And we already know it's 20 times cheaper, but also it's actually better than the employees at reading the mind of the user. And there could be multiple reasons for that. It could be that, GPT knows about topics that the human doesn't know about. So there could be like technical queries, or there could be location-based queries. So this was just I find this to be a kind of astounding result, but also, and that's why we wanted to replicate it on public data as well. But it's also kind of pretty new. So it just came out last week. So we're still sort of, it'd be interesting to get people's feedback maybe on this kind of stuff and discuss during the workshop.
So could you interpret this as saying that you actually made your guidelines better? I started the first relevance stuff in MSN Search with 8 pages of guidelines.
Yep.
Now, I know that we are probably when I say we, I just mean Microsoft. We're probably in the hundreds of pages, and you said Google is 170 pages or something. So is it a question of too many pages confusing the heck out of people, the reviewing people? And are you making it simpler and at some level taking a kind test as more or less good?
Yeah, it could be like wrong guidelines or confusing guidelines could be a reason. But also this kind of world knowledge thing, where it just knows, it's read the web and it knows a lot of things. Yeah. All right.
You didn't feed it the guidelines at all when you did the...
Yeah, let me talk about it. Yeah. So one is you could feed it, your hundreds of pages of guidelines into the LLM as well, but we didn't do that. What we did for the public replication, we can actually show you the prompt. And it's not very readable probably on this screen, but we first describe we actually had a sentence to say, what's your role? And so we say, you're a search quality rater evaluating web pages. This is sometimes people put a role into a prompt to kind of get the system thinking about, some of the world knowledge it has. And so that you can say the role, you can say what's the rating scale, you can say something about the scenario. And here we took the scenario, because we're doing robust 04 actually. In this part, we were more careful to actually add in, assume you're writing a report on a subject of the topic. So we're going to give them a query topic and assume you're writing a report. So this is actually taken from the guidelines that was used at NIST for judging robust 04. And then we've got what's the query, but also what's the description and narrative, because we actually we can add into the prompt a description of, we got extra information from the query originator on what this query is about. And they actually said, I want these kinds of results. I actually didn't include an example in this version of the slides, because I've just, dropped some in, but it's basically if the query is Hubble telescope achievements, then the person who came up with the query might say, I'm interested in achievements, but I'm not interested in just information about problems or repairs of the Hubble telescope. I'm mainly interested in what scientific knowledge we've gotten and how that was useful. So there's kind of an extra description from the real, if you'd asked someone, what's this about, and they gave you more information, we can include that in the prompt, basically. And this is, the question is, if we do that, will the labels get better? There's also a kind of thing of, let's think through this in steps, or think through aspects of what makes a good page. So that's these aspects here. And then there's also this one that is called multiple, which says, you could ask in the prompt, simulate 5 judges, or something like that, just to see if you get some variation. And so we tried these things. So we've got the R, D, N, A, M. So that's 32 combinations. And we just tried that on 3,000 labels. And these labels come from the query originator in the Trek model. So it's kind of like gold data, but also for kind of a fake task. But it's really somebody who really understood what this query means, who wrote the narrative of what the query means, also did the ground truth relevance judgments that we're trying to match against in this thing. And interestingly, this RDNAM, where you do everything, was something that was inspired by Bing, but actually, things that we found were interesting to try in Bing, but it actually doesn't win. Doesn't win. It's actually the DNA prompt that wins on our metrics, which is how much do you agree on these 3,000 cases with the judgments that came from the query originator. All right, I'm going to speed up because I want to get back to the original talk. We also tried some paraphrases of the prompt. So our results on the public data are that it makes a huge difference, these 32 versions of the prompt. So the worst version of the prompt is down here. This is a metric where 0 is random. So Cohen's kappa. So this is where we're doing worst out of the 32 options. The vanilla one, where we don't turn on any of our prompt ideas, is here. And the best one is the DNA prompt is here. And then we tried paraphrases of the DNA prompt as well. And we did some tests for like stability of the result across different splits of the data and things like that that are in the paper. But, and then if we look at other reported results on this metric, like we've again got this thing where the GPT-4 model is doing actually better at agreeing with these gold labels than other approaches. So that's the latest news from this paper last week that's up on archive. And so now we're back to the talk. So do we need another MS Marco? Well, if we can generate queries and we can generate labels, like it's going to be interesting to figure out like what to do. Like I showed that like learning from one MS Marco investment in labeling doesn't translate to these health or newswire data sets. So, you know, maybe synthetic data is a good idea. Maybe the final evaluation should still be like human-based, though, if we want to trust it, or some hybrid, because, you know, people are trying these different hybrid things. Like, in some sense, what we're talking about is LLM labels monitored by humans, for example. Yeah, and then what about biases and harms? Let me move on just so I can cover some of the other content. So we've just seen like some synthetic data without much context from the user. So I thought it would be fun to just I asked GPT-4, please list some examples of search personalization. You know, what's the search, what's the query, what's the effect of the personalization? And so here's the output, but I've just summarized it in a bigger font up here. And it says, yeah, you could be searching for pizza, and it matters if you're where you are. Like, what if you're in, you know, Chicago, or if you're searching for flights? It could matter what's your favorite airline. It could matter like what your budget is. And if you're searching on Netflix for the best movies, you know, are you a horror movie fan versus something else? These are all ways of personalizing. And in some ways, you know, it knows these examples. It's probably like read Ryen's papers during training or whatever. You know, it knows a bunch of stuff about this kind of thing. So this example I took from Andrew Ng gave this talk where he said, data is the new gold or new oil or whatever. And he said, well, you know, Andrew knows how to build, you know, a search engine, having worked at Google and Baidu, but doesn't have the data you need to build a search engine. And the example he gave was, if the user types the query United in the UK, they mean something different from someone in the US, because one is football and one is an airline, more likely, according to the data, but the data is proprietary. So I actually just tried synthetic data. I said, generate JSON that describes a user who is in South London and they type United. So I haven't said football, I've just said United. And it says, oh, okay, there's a user, they've got an ID, 1, 2, 3, 4, 5, 6, 7, 8, 9. They've got a location, they've got a device on a certain date and time and so on, the query is United. And then I said in the same prompt, these are the toy examples in case we've lost context on this. This is just me playing around to see what it can do. Now write a separate JSON record indicating the likely intent of the user, and it says informational intent for sports, football, Manchester United. So this is just JSON generated by GPT-4 for this scenario. And I do the same thing in Austin, Texas, and has a bunch of stuff. It even generates a lat long as well, and just, you know, makes up a whole lot of stuff. And then I say, well, you know, what did they want? And it says informational travel airlines, United Airlines. So it's basically, it kind of can guess that example. Because my talk was in Austin, I then also did barbecue. So this is like, take a whole set of barbecue places, feed in the tokens here, and tell GPT-4, considering the web page content above, please list the criteria that you would use to decide between the options. And it's saying location, style, atmosphere, price, and availability. Availability is how easy or hard is it to get the barbecue. Do they have to order online, make a reservation, wait in line, etc.? Sorry?
What's the result? I'm from Austin, so
Oh yeah, we're getting there. Yeah. No, actually,
you got the gold standard.
You're the gold standard. Yeah. Okay, so and then I thought, what did I really need to give it a web page for it to know this? And it actually had a whole lot of similar ideas, even without the grounding text that I provided in the previous slide. But with the grounding text, what I wanted to do then is say, okay, I'm in downtown Austin. I don't care too much. I just want something convenient. And it said Lambert's, Cooper's, and Iron Works. So I don't know. Yep. Okay. Good. And then I also knew from this guy, Jeff Dalton had told me that Franklin Barbecue is the one that he would go to. Oh, and Leif, you went there too. Yeah. With
long lines.
so I said, okay, what if I'm a real stickler? And it did work. I said, I don't mind if I need to order online or wait. And it says Franklin and these other ones. So yeah, it basically matched the ground truth to some degree, based on context, a bit like recommendation, so it's sort of, yeah, I mean, this is basically recommendation. So it seems pretty good at just, getting things from context. Just for fun, I said, turn the web page into JSON, and it kind of did something that wasn't really that good. And then I also said, like, if I take the JSON version, just because I was playing around with it, and then I say the scenario user. So this is like the scenario I was showing just for like, if you wanted to generate a new MS Marco without context, you could just say, here's a page, what's the query? This is more like, here's a page, here's a detailed scenario, and then I'm saying, what's the structured kind of synthetic data you could generate around this scenario? So I basically said, I've said, so instead of saying the user wants a certain document, I've said the user wants Franklin Barbecue. So how would you describe this user? And it's generated this JSON, which is like, the person's name is Alex, the query is best barbecue in Austin, and price is not a factor, and wait time is willing to queue, and reputation is important, and apparently it's a lunch, and so on. So like this is this is kind of synthetic data, but with context. How am I going for time?
Like another 10 minutes.
Okay, yeah. So,
yeah. Go back a few slides. I recall there was like somewhere mentioning like vegan options. I was wondering like if it would like voluntarily like provide these information, or do you have to like very like specifically ask for it?
Yeah.
Anything for, like,
yeah, and this was the completely ungrounded one. So when I actually didn't give it more input from like a web page, it was the GPT that actually came up with the vegan option as an interesting thing. So that was actually something that probably wasn't listed in the web page I was giving. So by not giving it a web page, it came up with this other thing like the vegan options. So yeah, it's interesting. Like, it's thinking of things that I didn't think of or that weren't in the page that I gave it, I guess. I shouldn't say things like thinking of. It's generating things that, yeah.
So Nick, what you're just showing in the slides that you were on, it's the other way mapping, right? So one is where you provide the criteria and get the answer. The other is you're giving the answer and say, well, what is a potential profile for this? So would you compare this to, query documents? So you're giving document generating query, another you're giving query generating document.
Or giving scenario and generating, multiple things. Yeah, like that's right. I'm doing all these things, I guess, in these examples. Yeah, I think that's true. Like if I say it's a person who wants to go to Franklin's, then I'm kind of giving a scenario, but then it's kind of generating the query here. So it's actually saying like, query best barbecue in Austin. So it's kind of from scenario to query in this case. But the query has all this extra stuff about the preferences of the user that's not captured in the query. So I've kind of like, it's like that thing with the Hubble telescope achievements. There's an extra description of the scenario, and I'm just sort of like turning the scenario into some kind of hallucinated JSON record. Yeah.
So I think evaluation is more challenging in this case, right? So the other one, you could generate ground truth in the sense, if you have the right people, like, hey, you're from Austin, you know barbecue. Are these like, or what would be your preference? What would be, right? Because there's a limited set. But this is potentially infinite set in terms of 8 billion people could have 8 billion profiles.
Yeah.
Which one matches, and so in terms of the evaluation, so if I were to evaluate how good this is, I mean, this looks good, but how do you think about ground truth?
It's like, what's your starting point for synthetic data, right? Like, and I think this is an argument we get into where if you're happy to just have a scenario, and like, you can generate a bunch of data around it and not worry about it. But if you're building a product, then like, what if you generate a whole lot of people who have bad taste in barbecue, or you do some like wrong thing? You're now training your system to do the wrong thing, or your data set's in one area, but your real users are doing completely different activities. So like, I think there's this question of like, so I think I can generate, a scenario. Given a scenario, I can generate the kind of details of the user and the request. I can also judge the relevance of results. I can do all these things, with this stuff. But like, there's this question of, does it match up with reality in some way, or is it just completely, is it synthetic in a bad way? So like, that's kind of the arguments that we get into sometimes. For example, like there was a paper at the same conference, the web conference from Spotify, where they said, well, what if certain catalog items have never been searched for, and so you want to generate synthetic data that helps you surface, songs that aren't parts of the catalog that are being missed. And so if you talk to a product person about that, then they can get into a discussion about, well, do we want to train our system on data that's not what users do? And so, you've got a scenario, they want this extremely tail song. And how are they going to search for it? I'm going to generate synthetic data. I'm going to train the model. But so I'm kind of more in favor of the synthetic data. Like, I think sometimes you don't have data. Sometimes the users aren't doing something yet. Sometimes it's a new product, you don't have users yet. Yeah. Sometimes, so like, I think being able to generate scenarios and make progress is handy. But then there's always the question of, does that match reality? And why did we spend time making our system do a thing that users never do?
Well, but this is back to your point about that irresponsible AI, right? So
yep.
If the users are misbehaving, they're getting bribes and all those things, then you generate synthetic data from that, then that's not probably what you want to do. So if you recognize that, and maybe the Spotify is like, that's not the case, but like in terms of if you want to increase diversity, historically people haven't done this, but that doesn't mean that's what you want to carry on.
That's right. Yeah. So I think there's both.
So you intentionally want to change that.
Actually, even without getting into issues of bribing and so on, how do you vary query popularity, and should you optimize for the more popular queries, or should you optimize across the board?
Yeah, exactly. Like all of these issues that came up, even when we had usage logs, now we can generate an even greater variety of things. I think it's a really interesting area.
I mean, one of the principles behind a lot of information retrieval is robust performance regardless of the frequency, right? If we optimize for frequency, we'd be going all in on navigational queries, not caring about
that's all.
Right.
Yeah.
Facebook logic.
Yeah. I just realized that maybe in the recording people can't hear the questions, so I'm not sure if this is how this room works. But anyway. Oh, it's okay? Okay.
There are microphones around.
Okay. I was figuring out if I should be repeating. Okay.
Sorry, wait, can I ask you a question? With respect to queries or questions that look like what users would do, and this problem that we don't have interaction data that actually resembles what people actually do, so we generate it. It seems like for document retrieval or for something broad where people have been sort of over 30 years trained that sometimes things are only partially relevant or the list isn't perfect or whatever, I think it seems more likely that those imperfect representations would be okay. But with AI, with the conversational AI, people are expecting a very precise, natural sounding, correct response. And so I wonder if the distance between what you can generate and what people actually do really matters in that sort of thing.
Yep. That makes sense. Yep.
Great.
Hi, Nick, this is great. Just wondering, are you aware of a recent publication from Harvard Business School? They're talking about a jagged frontier of AI capabilities. So basically, the AI capability, if this is the like the boundary of the human capability, and the AI is kind of something like this, kind of weird. So some parts is doing awesome, like here, and in some other things, like my own experience, like reference search. I don't think it does a good job.
Yep.
So maybe it's only because GPT is pretty good in finding barbecues. Or for all those web, this daily life business. So how do you comment on that?
Yeah, I think, I'm constantly wrestling with things that it's not very good at. And I think that but it's just weird that of all the things, the toy examples I tried, it kind of worked okay. So I don't know what that means. Yeah.
So this is super interesting because when I'm looking at it, it's like, okay, if you have a product, you can get your target segment customer really focused. And then essentially that JSON to me is like the target customer for this barbecue, right? So the question comes from me is like, one, how did find that target customer where those issue comes? That's one. The second thing, can I validate that when I create so many of that one? Then suddenly I can do many things with that. Correct. I can target, give them much better, faster result, give them leverage the product that's sectored in a certain way to change the website. You can do all kinds of stuff now suddenly. Does it make sense?
Yeah. I think and it's this kind of question of how does it match with reality is kind of one of the key questions. Like you can have this great, profile and understanding, but is it an understanding of a real user or is it an understanding of like a made-up user? And does the made-up user look like any real user? But so how to measure those things of like, because if you really could perfectly represent what's going on in reality, like these seem pretty good. But if you're getting better and better at representing reality, then there's a lot of applications. I agree. Yeah.
What does it use to come up with that one? Even if it's hallucinating, whatever that, like how do you come up with those so specific, right? I'm just trying to figure that. Any idea?
I mean, it's seen a lot of JSON during training, but it's really, it's a good question, I guess. It's good at generating, it can generate code in JSON as well as language. And so this is in some ways, like if I'd said generate a natural language description, or if I'd said convert a natural language description to JSON or back and forth, it can probably do those things, maybe. I don't know.
The more important, for me at least, I'm trying to understand the price, not a factor, correct? Why that particular not a factor, it comes into that one, or the quality of high brisket. I think those are that assign the personality to the person who really evaluate that one. Type, celebration, occasion, would look for that one. Does it make sense?
So I think it can do it in, one interesting thing, I mean, it's not exactly what you're saying, is that it can do it in both directions. So I can say, if I want the best of the best, what should I get? And it says Franklin. And so that means I'd have to be willing to order online for pickup at least a week in advance, and so it knows these things. And then, the reverse version is that I've said Franklin and now it's saying willing to wait. So it's kind of like, it's got an association between Franklin and willing to wait that it can do in both directions. Because this one, I'm saying I'm willing to wait and it says Franklin. And this one, I'm saying it's Franklin and it says I'm willing to wait.
The data is basically on the web page context, not a review, nothing that.
Yeah. That's right. It's a page just listing a bunch of places. Although, I didn't try the version where I just ask it and it already knows the answer, which can work in some cases. Yeah.
So like in one of your previous examples, I think it was United, where you also had confidence level. And I don't, or confidence.
Yeah, it generated.
And you didn't ask for that explicitly.
Yeah.
But I mean, do you think something like that could be useful for these things in terms of, again, going back to evaluation, like how much, we want to, like if you want to do a non-binary thing.
Yeah. No, that's interesting too. Yeah, I mean, yeah, and if you're generating relevance labels, what scale are they on, and all those questions. Yeah, that's true. Am I out of time, basically?
Well, because we're integrating Q&A and that, I'm fine. I think, go ahead,
Yeah, so I guess this is the same question repeating again and again, but what you have shown is like a prompt engineering. So you might have a different, the other team might come up with a different like a prompt and say, oh, this is making better results. So I think it became more like art instead of like science. So how can you like evaluate this model and the performance of the other model?
Yeah, I think that's the hugest problem. How do you make sure this is meaningful? Or is it just all circular reasoning with things generating things that feed into things? And so like that's why in that preprint we said, okay, we're actually going to get the opinion of what's relevant from the query originator. So we're going to actually know exactly what this person thought was good or bad. And now it's grounded in reality because we're actually getting a few examples of this gold relevance judgment. And so then the prompt engineering in that paper has a target because it's like saying, I'm going to use a small number of opinions from real users to decide between a few different prompt options.
Then the next question is, do we actually need to, make the model optimize to like the real users' behavior? Like the machine intelligence and the human intelligence, maybe the machine intelligence give a different type of query, but which is much better than the user natural language query.
Yeah, it can probably generate quite elaborate things, for sure. Yeah, I think, I've got a section that we won't get to where I just show an example of conversation, and you could imagine it generating some kind of conversation that looks quite detailed and more complex than what a human conversation would look like. Maybe I should just show that example and wrap up. What's the button you press to choose slides? So in the conversational section, I just looked at a bunch of things related to conversation. And one of the things that we wanted in our theoretical model for conversational search is to have this process of user revealment, which is the user reveals what they want, and the system reveals what it knows, and you go back and forth. And we had these 5 principles, but a couple of them were about revealment. And so I just tried with GPT to, I've kind of summarized it. These are exactly the characters. I've just changed the new lines and things to fit it in a slide. So this is me where I said to GPT-4, this is like an example of revealment is to play 20 questions where you slowly build up your knowledge of what's going on. And when we wrote this paper, we were thinking of 20 questions, a few years ago as an interesting case of revealment back and forth between me and the system. But we didn't actually implement it. Whereas here, I'm just doing it, in GPT-4. So I was actually thinking of dragon fruit to make it difficult. And GPT-4 asked, is it alive? And I say yes. Is it an animal? No. Is it a plant? Yes. It gets a bit tricky where it says, is it red? And I said yes. And it said, is it round? And I said, yes. But maybe I'm not doing a great job here. Does it grow on a vine? Yes. So it had a bunch of things, and then I said, you've run out. The answer was dragon fruit. Does that make sense? And it says, there's a few possible ways to respond to this question. One is, yes, that makes sense. I didn't know about dragon fruit. How do you eat it? Another one is, no, it doesn't make sense. It's not really red, and it's not very round. And I thought it grew on a cactus, not a vine. So I actually went to Bing and searched, and yeah, it's a cactus vine, basically. I also probed it a bit. We can kind of skip this, but like I started asking what it knows. I asked it, is it red? And it says it can be red, but not always, and things like that. It's somewhat round, but not perfectly spherical. So like I asked it a few things, and I asked it the reverse. I asked if it's purple, and it actually said no, which is weird. But anyway, so maybe it's not. So I just tried again. And yeah, we had much more success the second time, where it was when it said, "Is it red?" I said no, and that seemed to help it. And so we got there in 16 steps. But yeah, like I think the point of the conversational part of this was just that, like, yeah, I mean, Bing Chat is conversational. All these conversational search things are coming up, and our ability to do certain things. Like another example I had is, a thing we wanted in that paper was to be able to say, "Give me something like this, except that." And so, sorry, I know I'm out of time, but let me just show you that too, because it's quite fun. Let's see. So I said, I'd like to watch a movie. And it says, what kind of movie? And I said, I want a drama. And it said, Shawshank Redemption or The Godfather. I said, I want something like The Godfather, but more recent. So we wanted to do similar to this, but that. And it says, oh, The Departed or The Town. And I said, those are great, but what about something from Korea? And it said, oh, Parasite or Old Boy. And I said, well, Parasite isn't exactly a crime drama, but I'll watch Old Boy, thanks. And it says, you're welcome. And then it actually generated extra conversation at the end that I didn't type. Yeah, so that's another example. Like, so we wanted to be able to do this stuff in our theoretical framework. And so these are the toy examples of that part. All right, thanks.
So Nick, so the whole point of all this is probably to replace the judgments and so on. And the point of the judgments is to improve your search. Why not just throw away the whole review bit in the middle? Just directly say, here's a set of results. Go party on it and give me a better ordering.
Yeah. I think there are papers on this as well of doing like re-ranking, like, there's a Google paper, I think, on point-wise, pairwise, and list-wise ranking using LLM prompts and things like that. So people are working on it, but if you want to search millions of items, you're probably not going to feed all of them into the prompt. So that's why I was mentioning distillation before, is probably like, if you think you know how to, even if you think you know how to re-rank the top items, which you may or may not know, for using LLMs, you won't be able to do the whole corpus using LLMs, I guess. And so, but yeah, it's a really good question. Like, it's sort of, I think we're in new territory, yeah.
Yeah, Fernando.
You've stayed in an English world here. Do these results generalized to other languages?
I think we've tried internally some things in other languages, but it's a really good question. I think obviously low resource languages are going to be, these things are not going to work as well. But I also think about the location-based ones I was doing, like if it's to do with a small town or if it's to do with some other country, even in English actually, if it's some like obscure part of Australia or something, it can no longer do the barbecue trick or whatever. Yeah, so I think that's I think what we need is more public open study of biases and limitations of this kind of stuff. But But yeah, so I think we put in a lot of those statements about we need to understand this better, and maybe propose even some public data sets or track or some kind of thing that says, how do we understand the problems here? Yeah.
More questions. How about some questions from students? Anchik, yeah.
You mentioned confidence level earlier, and I was curious if there's any evidence that when the LLM is providing confidence level, is that hallucination typically, or is there some sort of tangible reality?
How much do we trust the confidence?
Yeah.
How much confidence we have in them?
It would be really interesting to know the answer to that. Yeah, I think I sort of feel like I had a slide. So I kind of gave a talk last week that had some, it didn't have the toy examples. It had more of the internal data. But I had a slide that was just a book on, there's a book on human-in-the-loop machine learning that was published a couple of years ago, and that I can get through my O'Reilly subscription or whatever. And it's got all the stuff about how to measure label quality and how to think about data and probably confidence levels, all this kind of stuff, like how to analyze it. And so I put up a slide that said, here's a book. Now we just need to do everything in this book except with LLMs and see how it works, right? So every kind of annotation, if you assume these annotations are useful or the synthetic data are useful, then every aspect of data quality and how they get used and can be revisited, I guess. Yeah.
Related to this, because I was also doing some experiments and trying to estimate degree of relevance for documents, and I was trying two different settings, either discrete degrees of relevance or continuous scores between 0 and 1. And what I noticed is for continuous scores, it's really not reliable, because these large language models, for some reason, they are never very confident. And for example, I could never get a score very close to 1. It was never possible. I don't know why this is happening, but.
Yeah. And then I've seen people say, well, I don't like my score distribution, so I'll tell it, and then it just does the opposite as well. It will respond to that, but not in a helpful way. So yeah, I think there's definitely interesting output distribution issues there. Yeah, that's true.
Wouldn't it be more useful to ask it, how did you compute this? How did you come to 0.67 there?
Yeah.
Explain your...
Yeah.
As opposed to, I don't like 0.67,
Yeah. No, I think, and getting explanations is a whole other area that's really interesting. Yeah, I think so. I don't know if we'll have a chance to, I'd like to hear if people are looking at that, because I sort of, given that we don't really know how these things are working, then do we trust their explanations? And at what point is the explanation generated? And does it reflect anything? But I think that's a really fun area too. Yeah. Because in some ways, the Franklin barbecue stuff had a bunch of explanatory stuff in it. So, it seemed to know the stuff and be able to tell me it. So, yeah, I think explanations is a fun area.
Your slides, you mentioned you use prompt to generate different options or evaluation criteria. I also did some experiments to ask GPT to generate options for some specific context. Some of them are doing very well. It can generate options from different aspects or dimensions. But some of them, they just paraphrasing the options from each other. So I wonder how you use prompt engineering to ask GPT to generate very different options instead of the subtle differences.
Yeah. I think we got a lot more benefit in that public data from using really big changes that we provided. We had these 32 options of prompts, and it gave us this range that goes from here to here. And then, the prompt paraphrases were these ones, which had a smaller range. We did paraphrases of the best one, and it kind of, it had a less range of possibilities. I think it's partially because I guess if you add something like the topic description in, you're giving it new information, whereas these were all just giving different instructions for the same information. Yeah, I don't know, because the problem, what I'm worried about is like this irresponsible AI thing is that like if you're going to really prompt engineer to a huge degree in a way that could almost overfit to quirks in the data, then you need to be really sure that your data is like this high quality gold data and not something that actually is a proxy. Like doing a huge amount of prompt engineering towards some biased proxy data would obviously be a bad idea, but yeah.
I'm wondering if there are opportunities here, and I'm sure you thought about this, about the diversity notion that by having these automated assessors, you can essentially diversify in planned ways the assessors, whether you're looking at personality or whether there's some way to identify underlying values, or maybe the AI itself can identify the important dimensions of diversity for a particular topic. Is that something that's being explored?
I think it's a great opportunity to. That sounds good to me, great to me, because like I think there's kind of like a. The first question was like, well, can we just get rid of the metrics and just run the LLM and we're done? And maybe some parts of the thing will head in that direction. But then the other way is you say, no, I'm actually interested in understanding search. I'm actually interested in understanding users. I want to know the different kinds of users and what they think and what's their process and how to really understand and improve. And I think there's a lot of opportunities in that area of like for people who actually want to understand search and advance our understanding of information access, like how to use these things to, how to understand things better and how to incorporate that into the systems, yeah.
Okay, so we're almost at time, so let's thank Nick again.